Hello there, my name is Jonathan Miller and welcome to the first video of this course on HACCP or Hazard Analysis and Critical Control Points. We will examine the history of the HACCP and its importance in regards to the food industry and food safety. Food is not only essential to our survival as a species, but in some parts of the world, it has become a critical part of our culture, leading to the development of techniques concerning the gathering, storing, and cooking of food. One of the key discoveries in our history was made by microbiologist Louis Pasteur, who learned that food spoils due to microorganisms which flourish when food is not stored properly, and this led to different methods of food preservation. The primary focus being to control the temperature and reduce the water content in food, as these are what support the growth of microorganisms. Due to this discovery and the work of other scientific minds, food preservation has improved significantly throughout the years and has brought food manufacturing to a global scale. Yet, with this expansion of logistics like transportation and storage, food safety and availability have also become important factors. Food can now be prepared and served anywhere at any time, at homes, in schools, aboard airplanes and ships, and even in outer space. In the 1950s, as space exploration was already taking off, the National Aeronautics and Space Administration, or NASA, saw the need for food for their astronauts during space travel, and with the limitations in food preparation and storage while in space, scientists developed a unique way to prepare these meals. Of course, food must be safe as well, so as not to introduce microbiological hazards into space. With NASA's risk-based thinking and dedication to quality assurance, they wanted a controlled procedure and environment during the manufacture of food to ensure overall quality. So, in the 1960s, Pillsbury Company took on the challenge to manufacture the first space food with NASA's directive to design a system for controlling food safety. Pillsbury developed the HACCP system. HACCP stands for Hazard Analysis and Critical Control Points. This is a system to prevent food safety hazards. HACCP is a systematic methodology to identify the potential risks and the critical control points, or CCP, in the ingredients, in the processes, and the environment in the manufacturing of food. As space travel became longer, Pillsbury further improved the HACCP system in collaboration with NASA and the US Army to be a proactive system. This is the HACCP we now have today. In 1967, the U.S. Food and Drug Administration, FDA, recognized HACCP and started implementing its concepts into the food manufacturing processes. It was then that the HACCP concepts made their way from the space program to commercial food manufacturing. The canning industry was the pioneer in the application, but more and more manufacturers adopt the system due to the increasing awareness of the public on health and food safety. This paved the way for HACCP to be recognized globally through the reports of international groups like the National Academy of Sciences in 1985, the International Commission for the Microbiological Specifications for Food in 1988, and the Codex Alimentarius Commission of the World Health Organization, or WHO. It is considered as an important element in the published standards of food safety management systems like ISO 22000, BRC Global Standard for Food Safety, and SQF Code. In its current form, HACCP has 7 principles. Principle 1, analyze the hazards. Identify potential food hazards. Hazards can be labeled as physical, chemical, or biological. Principle 2, identify critical control points. These are the points in the manufacturing processes at which potential hazards can be controlled, reduced, or eliminated. Principle 3, establish critical limits for each critical control point. This sets the minimum or maximum limits for the control points, which include but not limited to temperature and time. Principle 4, establish monitoring procedures. These are the steps on what, when, where, how, and by whom the critical points are monitored. Principle 5, establish corrective actions. These are the actions to take when the critical limits are not met. Principle 6, establish verification procedures. These are the steps to verify the measurements in the monitoring of the critical points. And lastly, Principle 7, establish record-keeping and documentation procedures. This principle is about maintaining the records related to the HACCP system, hazards controlling and monitoring, corrective action implementation, and the validation studies. In this course, we will be discussing in detail these 7 principles and the other steps to establish and implement an effective HACCP system. I'm looking forward to seeing you in the next video. Hi, welcome to this next lecture video. In this lecture, we will discuss food safety hazards and the different types. Before we get started, let us define some terms to be able to understand the context of the topic. In case you didn't know, There is actually a proper definition of what constitutes as food. Per ISO 22000 version 2018, food is defined as a substance or ingredient, whether processed, semi-processed, or raw, which is intended for consumption and includes drink and any substance which has been used in the manufacture, preparation, or treatment of food. Now, food safety hazards are agents found in food that can be biological, chemical, or physical in nature with potential to cause adverse health effects. These also include allergens and radiological substances. In the context of HACCP, all these food safety hazards must be identified so the risk can be assessed. Risk, in the context of food safety, is a result of the likelihood or probability of the adverse health effect and the severity of the effect when exposed to that hazard. Let us start with the physical hazards. These are foreign materials intentionally or unintentionally added to food. Foreign in the sense that it should not be part of the product or has a different composition or physical characteristics from the food, and it is meant to be removed during the processing of food. Classification of physical hazards can be based on the incidence of occurrence. The first classification, it is an extraneous foreign body. This means that the physical hazard is unintentionally added and occurs due to various activities in the processing, storage, and transportation of raw and processed food materials. This includes stone, wood, metal, string, plastic, hair, glass, and the like. The second classification is the intrinsic nature of the foreign body. This means that the hazard or the unwanted material naturally occurs in the food. This may include seeds and fruits, shells from eggs, bones and meats, feathers and leaves. Depending on the regulation, not all foreign bodies can cause injuries. Under US FDA, a hard and sharp object between 7 millimeters to 25 millimeters in length in ready-to-eat food can be considered as physical hazards. Several cases and studies consider 7 millimeter as the threshold for foreign bodies. Anything less than this threshold may not pose significant risk to individuals, unless they are in special groups like infants and the elderly. Local regulations may actually vary from region to region. Regardless, these foreign bodies must be removed, and there are several detection and removal methods that are utilized, which include metal detectors, x-rays, filters, sifters, and even magnets. The next type of hazard is chemical. These are chemical contaminants in food which are naturally occurring, intentionally added as part of its processing, or unintentionally added during the activities in the food chain. However, at certain concentration or exposure levels, these can cause illnesses or chronic diseases. Some of the chemical hazards in the food industry include mycotoxins, food additives, pesticides from agricultural products, and environmental contaminants like heavy metals, which include arsenic, lead, cadmium, and mercury. Again, refer to your local regulatory standards or published journals on the tolerance or acceptable level of these chemicals. In some references, allergens are considered as chemical hazards. Allergens are any substance that can trigger an abnormal immunoresponse to a person. This response or the allergic reaction includes skin rash, inflammation of the face and body parts, to severe cases of anaphylactic shock and even death. These allergens are typically naturally occurring. There are several food allergens identified and varies region to region, but the most common food allergens include peanuts, tree nuts like hazelnuts, pecan, and walnuts, milk, eggs and poultry products, seafood like fish, crustaceans, and seashells, soy, wheat, and sulfites. Avoidance is essential for those suffering from food allergies, so it is important that cross-contamination does not occur in any part of the processing, and if there is presence, these food allergens be declared appropriately in packaging. The last type is the biological hazard. These are organisms present in food that are pathogenic, which means it can pose food safety risks to the consumers. These can be identified as bacteria, parasites, and viruses. There are several biological hazards in food which cause serious foodborne illnesses and even death, including E. coli, Clostridium botulinum, which causes botulism, and Salmonella, which is commonly found in poultry products. A biological hazard can be further classified into non-spore forming or spore forming. A spore is a single cell capable of growing or reproduction without uniting with another cell. The former includes most of the viruses, parasites, and bacteria. The latter, spore-forming microorganisms, can produce spores that can be heat and chemical resistant and able to produce toxins which are pathogenic, making these hazards more difficult to control. The growth of microbiological hazards causing foodborne illnesses can be controlled by certain conditions, and to help remember these conditions, a common mnemonic used is FAT-TOM. This stands for food, acidity, time, temperature, oxygen, and moisture. Food. The nutrients in food promote the growth of these microorganisms. Protein-rich food like meat, milk, fish, and egg can harbor these pathogens. Acidity. This next condition is about the pH level of the food. Microorganisms thrive in the neutral range, between pH 6.6 to 7.5. Some may still survive until acid level of pH 4.6. With this, the US FDA requires acidified food to have a pH below 4.5. This is the reason pickling or immersing food in acidic solution is an effective preserving technique. The first T in the acronym is time. If food is placed in a favorable condition for the microorganisms, it is only a matter of time for them to grow exponentially. Perishables like meat can be spoiled within 2 to 4 hours. The second T is temperature. Most microorganisms grow at a temperature range between 5 to 57 degrees Celsius. This is often referred to as the temperature danger zone. In most cases, microorganisms can be killed at higher temperatures. But if the spore has become resistant to heat, temperature may not be effective to remove them. O is for oxygen. Most pathogenic microorganisms need oxygen to survive. This is the reason food is stored in tight packaging. Canning food is the best example for this. This is one of the reasons canned foods have long expiration dates. In recent years, the atmosphere inside the packaging has been modified. This concept is called modified atmospheric packaging, or MAP. As the product is packed and sealed, oxygen is flushed out by flushing in an inert gas like nitrogen. This is applied in packaged snacks and bottled beverages. Last is M for moisture. Moisture is the amount of available water present in food. Like humans, microorganisms need water to survive. In food, moisture is measured in terms of water activity. This measure is in the range of 0 to 1. The closer the value to 1, the more available water is present. The favorable condition is a water activity between 0.95 to 1. So, lower than this range means less favorable for their growth. In summary, food safety hazards can be physical, chemical, and biological. These hazards can be naturally occurring or intentionally added as part of its processing. As we recognize these hazards, it is important to always refer to the local regulatory and standards and scientific studies journals on the tolerable and acceptable levels as well as the adverse effects. This information will be helpful as we create the HACCP plan. That's it for this video, and we'll see you in the next one. Hi, welcome to this lecture video. We are now about to start creating the HACCP plan, but before even beginning with the first step, the organization must assess the need for the implementation of HACCP. The drive or motivation in doing the HACCP can be, one, from the regulatory body requiring the use of the system as part of the business, and second, is based on the requirements of the customer. When implemented correctly, HACCP provides assurance that the product is safe for consumption. In this course, we will discuss the 12 steps in the HACCP plan. The first 5 steps of HACCP are assemble the HACCP team, describe the product, describe the intended use in consumers, create the flow diagram, verify the flow diagram. In this video, we will go through the first step, assemble the HACCP team. Like any other management system or plan, it is always a team with a balanced representation and expertise. Let's talk about balanced representation. The HACCP team must be composed of people with knowledge, experience, and authority on the processes concerned with the products. Representatives from the operations in process and packaging, quality assurance or QA, research and development or R&D, warehousing and distribution must be part of the team. The goal is to have a holistic approach in creating the HACCP from raw materials up to the distribution. These representatives can also be the experts in their respective functions and have adequate knowledge in the concepts of HACCP. But external facilitators or consultants can be an additional support in developing the HACCP. There is no written standard on the number of members, but typical is around 4 to 6, depending on the complexity of the process, the size, and structure of the organization. It is recommended to have a team leader to hold and guide the team throughout the steps. In some cases, manufacturing staff, like operators, are included in the HACCP team since they will be the frontliners in monitoring and ensuring the critical control points or CCP. While the top management may not be part of the team, the role is to provide the necessary resources in the implementation and communication of the HACCP system. Members of the team and the hired external consultants, if any, must be trained or certified on HACCP principles to be able to develop, implement, and maintain the system in the organization. Proof of qualifications and competency must be documented. Once the HACCP team is set, we can now proceed with the second step, which we'll talk about in the next video. I'll see you there. Let's jump right in talking about the second step of HACCP, which is describing the product and distribution requirements. This step provides the scope of the HACCP system from the identification of the hazards and the possible controls that it may encounter throughout the process. This step should be able to answer the following questions. What are the products or the product line? What are the standards to apply? And what are the processing and the distribution requirements? To provide an illustration, we will consider bread as the product, which answers the first question, what is the product? Even when multiple bread types are being produced, only one kind is considered for the design of the HACCP system. Say that the team decided to focus the system on the loaf bread line. In the product description, the brand and product of the loaf bread needs to be declared. The declaration of the product composition or ingredients printed on the packaging can be included as well. For this, the ingredients of the loaf bread are flour, sugar, eggs, milk, emulsifiers, and preservatives, or whatever is in the packaging. Processing aids and the utilities such as compressed air, cooling water, and the like can be declared here as well. The end product characteristics and the acceptable levels can be defined. This can include the standard specifications of the product, like product dimensions, sensory attributes, physical, chemical, and biological properties of the intermediate and final products, and the quality plan for the product can be indicated as reference. The processes and/or preservation methods and the distribution methods are also determined. In the case of loaf bread, the production processes are the steps in creating bread, which include mixing, dough kneading, baking, cooling, and packaging. The type of the packaging materials or other technical specifications of the products can be indicated. Distribution methods are the activities involved in the handling, storage, and transport of the products. This would be noted as such. Products are placed in plastic trays, then transported to a finished goods warehouse where it is distributed via closed trucks or container vans. The storage condition is ambient in a dry place away from the sunlight. In summary, the product description and other related technical specifications are defined and specified by the HACCP team that may help them in the review and analysis of the risk in ensuring product safety. That's all for this video. See you in the next one where we talk about step 3. Hello there, welcome back. We already formed the team and defined the product characteristics, so now it's time to describe the product's intended use and the consumer. Why is this step important? The team must design the HACCP system that is suitable for the expected use and the consumers who will be consuming the products. This is also considering a part of the general population or special groups like infants, the elderly, and the immunocompromised, or those with specific health conditions who may be consuming the product. In this step, the system must also recognize the potential abuse or mishandling of the product. What should be considered in this step? Well, that would be the use in preparation. For example, a loaf of bread. No preparation is needed to consume it. It's ready to eat. For food products that need preparation before it can be eaten, these steps have to be defined and noted. Say, brewing coffee. The preparation would be set the coffee filter, add coffee grounds, add hot water, and brew. Next to be noted is the product's intended use, which for bread is to be eaten. What age group is the product meant to be consumed by? It's important to note whether foods are meant for specific stages in a person's life. For example, baby formula, which is meant for very young children due to the specific nutritional needs of a child. Who are the people that should not consume this product? In this instance, the team can consider the special groups like people with allergies or health conditions. At this point, the team should have a clear idea on the product and its characteristics that are suitable to its intended use. In the next lecture, we will now map and understand the processes involved in the manufacture of the product through creating a flow diagram. I'll see you there. this next lecture video. In this lecture, we will now discuss the importance of the flow diagram in the design and implementation of the HACCP system. Now, what is a flow diagram? A flow diagram, or a flow chart, is a visual tool to show the sequence of processes, systems, and decision points step by step. In the context of the HACCP system, the flow chart describes the production process from the receiving of the raw materials to the transport of the final product, and every step in between. Why is creating the flow diagram an important step? Well, the flow diagram ensures the processes that can have an impact on food safety are not overlooked, so the flow diagram needs to be detailed, and every step will be scrutinized by the team to analyze potential hazards, physical, chemical, and biological. Flow diagrams need to be clear, accurate, and sufficiently detailed to the extent needed to conduct the hazard analysis. How do we create a flow diagram? Flow diagrams use symbols to represent each step or essential part of the production process. These symbols are connected with arrows to show the direction or flow of the processes. Typical symbols used in flowcharts are as follows. A rectangle represents process. A parallelogram is the symbol for the input or output of a process, i.e. sugar being added or removed. A diamond is the symbol for a decision concerning the production process. An oblong is the symbol for the start and end of the process flow. For our example of a loaf of bread, here is a simple process flow diagram. As you can see, the important processes are shown in the flowchart. This flowchart covers the start in the receiving of the raw materials and packaging materials, and the end in the transport of the finished goods. Aside from the flow of the good materials, decision for rework is shown in the dough forming. Non-conforming materials and products, dough, and the bread have their own flow to show the disposition for these items. In some diagrams, numbering can be included in the step or symbol to help organize additional steps in each sequence. If the team is initially mapping the process, it is helpful to draw a rough flowchart by hand while on site. In this way, the entire production flow is clearly understood, and corrections or changes can be done quickly. Once the team agreed on the initial drawing, the flow diagram can be transferred via the computer to generate a digital version. Even with the drawn description, it's important to define each step as clearly as possible, starting with process description. The process description contains the general objective of the step, like the transformation of the materials and the equipment being used. Basically, it describes the process briefly. The description can be broad or specific, depending on the impact of food safety. For example, the process description for the receiving and storing of raw materials can be stated. The materials are transferred from the raw materials warehouse to the plant's receiving area where these are received, inspected, and staged prior to use in production. For processes with critical impact to food safety like baking, the process description can be stated like this. The dough is baked for a total of 30 minutes through a tunnel oven with 4 distinct zones, with each zone maintaining temperatures between 160 to 240 degrees Celsius to cook the dough thoroughly, achieve the required internal temperature, and moisture and form the crust of the loaf bread. If needed, critical process parameters that are maintained or measured need to be stated. Process step layout and environmental requirement. The layout or the location where the process is carried out can be shown. In some HACCP documents, the layout map of the plant is attached as an additional reference. This allows the team or the readers of the HACCP document to have a picture of the process being described or have a reference on where the process can be seen, which will be helpful in the verification of the process flow. If the process needs to be carried out in certain environmental conditions, like temperature and humidity, this can be stated as well. For example, if the raw materials need to be in the cold room, the maintaining temperature and the minimum or maximum time these are stored can be included in the description. In summary, the flow diagram is a good tool to see the overall transformations involved in the making of the product. This will help in the succeeding steps of HACCP and ensure there are no steps overlooked or taken for granted. In the next step, we will now confirm the accuracy of the flow diagram. I'll see you there. Hi, welcome to this next lecture video. In this video, we will discuss the 5th step of the 12-step HACCP system, which is to verify the flow diagram. At this point, the team has developed the process flow diagram of the product, which starts from the receiving of the raw materials until the distribution of the final products. It is essential the team reviews and verifies their information on the production process multiple times if needed to ensure the flow diagram's accuracy. Why is it important to do this step? Well, any inaccuracies in the determination and analysis of the hazards may have undesirable consequences, and when it comes to food production, those consequences can be life-threatening. This is also a walkthrough activity. This means that the person or persons assigned to do the verification must be on site checking the flow of the materials and sequence of the processes, and the individual selected must be a member of the organization or the HACCP team. Now, when is the flow diagram verified? Verification is not a one-time occurrence, though. There is no hard rule on the frequency of the verification. However, in most implementations, the flow diagram is reviewed at least once a year. If there are modifications in the production line, like changing of equipment, relocation of the line, new standard work processes, and the like, the flow diagram must be reviewed and updated to ensure that hazards are captured. The communication of changes to the affected stakeholders must be reviewed as well in this step. For proper documentation of this activity, the process flow diagram may be signed by those who have verified. Now, we have completed the preliminary steps of the 12-step HACCP. Let us review those steps. Assemble the HACCP team, describe the product, describe the intended use and consumers, create the flow diagram, and verify the flow diagram. Accomplishing these steps will prepare the team to develop an accurate and coherent HACCP system. We can now begin with the discussion on the HACCP principles. We'll talk about those in the next video. Hi, welcome to this next lecture video. In this video, we will discuss the 6th step and what some consider the most important step of the 12-step HACCP system: conduct hazard analysis. It's important to recognize as the foundation of the following principal steps. As a review, food safety hazards are agents found in food that can be biological, chemical, or physical in nature with potential to cause adverse health effects. All these food safety hazards must be identified and the risk assessed, and in regard to food safety, this means knowing the likelihood or probability of adverse health effects and the severity of the effect when exposed to that hazard. Physical hazards are foreign objects intentionally or unintentionally added to food. Physical hazards can be classified based on the incidence of occurrence. First, extraneous foreign bodies which are unintentionally added like stones, wood, metal, string, hair, glass, and the like. And second, intrinsic foreign bodies which are unwanted but naturally occurring, like shells on a crustacean, seeds, or feather. Depending on the regulation, physical hazards are hard and sharp objects between 7 millimeters to 25 millimeters in length. Next, chemical hazards are chemical contaminants in food which are naturally occurring, intentionally added as part of its processing, or unintentionally added during the activities in the food chain at certain concentration levels. If the concentration exceeds the allowed exposure levels, these can cause illnesses or chronic diseases. Allergens are also considered chemical hazards, and in case you don't know, allergens are any substances that can trigger an abnormal immune response to the person. The last type of hazard is the biological hazard. These are organisms present in food that are pathogenic, which means they can pose food safety risks to the consumers. These can be identified as bacteria, parasites, and viruses. The growth of microbiological hazards in food can be controlled with the understanding of food, acidity, time, temperature, oxygen, and moisture, or more commonly remembered by its mnemonic, Fat Tom. Feel free to refer to the details and examples of the hazards in the earlier videos if needed. Now, hazard analysis has two main activities. The first activity is the hazard identification, then the second activity is the hazard assessment. Let us discuss the first, hazard identification. Hazard identification is the understanding of how food safety hazards can be in the raw materials and processes and the control measures to eliminate or reduce them to an acceptable level. The risk is also gauged by determining the severity of the adverse health effects and the probability of the hazard occurring. For raw materials, all ingredients used in making the product, including processing aids, are to be considered for risk of physical, chemical, and biological hazards. More so, even reworks or recycled materials are also evaluated. There are several aspects to investigate, like sensitive ingredients that have hazards in it. Sensitive, in the context of HACCP, are ingredients that are likely to have the hazard. Remember our example of the loaf of bread? One ingredient is eggs. This is a sensitive ingredient since eggs contain salmonella, a foodborne microbiological hazard. Another ingredient is flour. This may have physical hazards like stones or metal from its processing steps and transport. In other words, the definition is based on the history of the raw materials. Another aspect to consider is the origin of the material, be it geographically or the supplier itself. In the assessment, all specific food safety hazards must be identified per raw material. I will emphasize, all hazards that can be introduced by the individual raw material to the finished product must be specified and identified. Even with an egg, it is not enough to note possible biological hazard. You must specifically identify salmonella as a hazard. Of course, a raw material can have more than one hazard. Flour, for example, is not solely at risk from physical hazards, but microbiological hazards as well. In some cases, where the proper steps were not taken, Bacillus cereus can be found within flour as well as pesticides or other chemicals used during its production. Aside from the raw materials, the processes identified in the flow diagram are also scrutinized. The environmental conditions like temperature and relative humidity, facility and equipment design, and possible traffic flow are considered for the process review. This is the reason why a process step layout or map is recommended in the development of the flow diagram in step 4. All processes from the receiving of raw materials until distribution and consumption are considered for the assessment, including allergens which may be present naturally to the raw material or may be introduced through cross-contamination. What is cross-contamination? If products A and B are manufactured in the same line, and product A contains allergenic material, there is a possibility that product B may be contaminated by the allergens from product A. So, it is important to consider the shared equipment in the hazard identification and the effectiveness of the control measures to prevent such instances. Note, in each hazard identified, appropriate control measures are in place to eliminate or reduce the hazard at an acceptable level. The control measures must be validated or scientifically proven to be effective as a control. The second activity in the hazard analysis is the hazard assessment. In each hazard, the team will assess the risk, evaluate the severity and the likelihood. Severity is defined as the degree of impact of the adverse health effects in relation to its intended use. The team can establish a scale to determine the degree of the severity. It can be descriptive like low, moderate, or high, with high resulting in life-threatening consequences. Most implementations of the step are using a scale with numerical figures rather than descriptive, with 1 as less severe to 3 as highly severe. As guidance, the following can be considered. What is the highest severity that can be experienced by the potential customer? What are the consequences of the hazard? The severity rating must be agreed by the team and is supported by scientific evidence. Likelihood or the probability to introduce hazard to the final product. The assessment of this factor is difficult, but there are considerations that can be used to establish the likelihood of the hazard. The first consideration is the product history. Is there an incident in the last 3 to 5 years related to this hazard? Are there patterns of occurrences? If the organization or the team is keeping records of the incidents in the operations or customer complaints, the likelihood can be agreed by the team. If there are no records yet, the team may rely on their experiences or compare them to similar operations or products in the industry. Another consideration is the current control measures in place. With the current control measure, how likely will the hazard occur? Is the control measure effective enough to minimize or prevent the occurrence? Like severity, there is a scale to be used, be it descriptive or numerical. In this case, likelihood can be rated 1, 3, and 5, with 1 as a rare occurrence and 5 as almost certain. The system of the scale for both severity and likelihood must be agreed upon by the team. The cross or product of the severity and the likelihood is the risk, or in other terms, significance. Using the scale, here is the severity likelihood matrix. In the first column is the likelihood, where the rating used is 1, 3, and 5. In the succeeding columns, the severity rating from 1 to 3 is placed. The products of severity and likelihood are placed on the cell where they crossed. In this case, a product of greater than 5 can be considered a significant risk, highlighted in red. Thus, if the risk is significant, there should be appropriate controls, which will be determined in the succeeding steps of HACCP. At this point, let us try to use the matrix in our example. Let us go back to the loaf of bread. We will conduct a hazard assessment on 2 ingredients, eggs and flour. Let's start with fresh eggs. The hazard identified is a microbiological hazard, salmonella. For the severity, this can be rated 3, critical. For this example, if there is no history of salmonella in the eggs being used, it can be rated 1, rare occurrence. If there are control measures like washing the eggs prior to being used and removing the salmonella, then the rating can be low as well. For this case, a severity of 3 and a likelihood of 1 will result to 3. Thus, the risk related to salmonella from the eggs is not significant. However, if the team rated the likelihood 3 or above due to the uncertainty of the salmonella's presence or the lack of effective control measures, then the risk becomes significant since the result is 9 or possibly 15. A similar approach can be done for the physical hazards in flour like stones. For the severity, this can be rated as 2, major. The likelihood score depends on the history or control measures. If the flour is to be used deceived so that these physical hazards are removed, then the likelihood is 1. Thus, the risk is not significant. This approach must be done for every identified hazard. Yes, the hazards will be many, and the identification is a challenging and time-consuming process, but this is the objective of this first HACCP principal step. HACCP is designed to protect against hazards that are reasonable to occur in consideration of its intended use. Thus, this risk-based approach is a proactive method to provide safe food products to the consumer, and once the significant hazards are identified, the appropriate control measures will be determined. I know that was a long one, guys, but I'll see you in the next video. Hi, welcome to this next lecture video. In this lecture, we will now determine the critical control points, which is the second HACCP principle. Once the hazards and risks are identified, appropriate control measures shall be selected. As defined in ISO 22000-2018 version, the control measures can be categorized into OPRP and CCP, but let's break down those acronyms. OPRP stands for Operational Prerequisite Programs and is a control measure or combination of control measures applied to prevent or reduce a significant food safety hazard to an acceptable level. This is where action criterion and measurement enables an effective control of the process and/or product. On the other hand, CCP stands for Critical Control Points. CCP is a step in the process at which control measures are applied to prevent or reduce a significant food safety hazard to an acceptable level, and with its defined critical limits and measurement, enables the application of corrections. Critical limit is a measurable value which separates acceptability from unacceptability. This is established to determine whether the CCP remains in control, and if the critical limit is not met, the products affected are to be handled as potentially unsafe products. So, what are the differences between the two? CCP is the last critical step to eliminate the hazard or reduce it to an acceptable level. CCP is related to the process step and not a general action. OPRP is the action related to the process step and not an intrinsic step, but it is crucial in preventing or reducing the significance of the food safety hazard to an acceptable level. To illustrate, let's consider baking bread. Baking can reduce the level of pathogens like E. coli. Baking is necessary in producing bread, and removing this step means the product will not be made. The step is critical, and control aspect of this step is time and temperature. The CCP in this process is the control of time and temperature. In the same way, contaminant detection through X-rays is another process to reduce the food safety risks. But is it a CCP? Well, X-ray detection is not an intrinsic step of bread making, meaning if this step is removed, the manufacturer can still produce safe bread. However, this step is essential to further lowering the significance of hazards. So, it is an OPRP. Other examples of OPRP in bread manufacturing may include sanitation of the pans to prevent cross-contamination and installation of CCTV to have a surveillance of the activities in production. There may be times when the distinction between CCP, OPRP, or PRP is not that easy to spot or clear. To make the decision systematic and logical, in the context of HACCP, decision trees were developed. What is a decision tree? A decision tree is a series of guide questions, and the answer to each question leads toward a decision whether each hazard identified during hazard analysis is a CCP or not. There are several decision trees available that can be used in CCP determination. The most used is the one developed by Codex Alimentarius Commission, the National Advisory Committee on Microbiological Criteria for Food, or NAC-MCF, the Canadian Food Inspection Agency, and by the FSSC 22000, which is based on the ISO 22000-2018 standard. The use of decision trees can be based on the applicability of the product or the mandated decision tree by the regulatory bodies or customers. Regardless of the decision tree used, the team must be able to use it correctly to come up with a CCP decision. Again, before doing the decision trees, the hazard analysis must be completed. As an example, let us have a closer look at the decision tree developed by FSSC 22000, which is based on the requirements of ISO 22000 Food Safety Management System, or FSMS. In this decision tree, there are 5 questions that need to be answered in the correct sequence as directed by the arrows. Let us use the baking process as the step to undergo the questions. The baking is evaluated as a process to eliminate or reduce the microbiological hazards, i.e. Salmonella, E. coli, from the dough and from the preceding steps. Question number 1. Is there a significant hazard at this step? Likelihood times severity. This question is qualifying if the hazard identified is above the acceptable significant rating. In the example of the severity likelihood matrix, a score of 6 and above is considered significant. If not significant, the appropriate control measure or prerequisite program, PRP, must be applied and the decision tree can be stopped. If the hazard has significant risk, it will proceed to the next question. Question number 2. Is it necessary to apply control measures at this step? In this question, it qualifies if the hazard in this step can be eliminated or reduced to an acceptable level in the control measures of the following steps in the process or in the food chain. In the example, there are no other steps throughout the process of bread making that can eliminate or reduce the microbiological hazards to an acceptable level. Thus, a control measure is necessary at this step, so the answer to the question is yes, which means we proceed to the next question. For instances when no is the answer, the appropriate control measures, or PRP, are applied, and the decision tree can be stopped at this point. Question number 3. Are control measures already in place? If the answer is no, then implement control measures by modifying the process, or the control measures be done by the supplier of the raw materials. In the baking step, there are currently control measures put in place, so the answer is yes. Proceed to question number 4. Question number 4. Is there any failure of the control measure with a high risk for the safety of the product? This question now depends on the robustness of the process and the current control measures put in place and implemented, based on documented history. This includes the control measures specifically applied to reduce to an acceptable level at this step and in the subsequent step. If the answer is no, the control measure is an OPRP. If yes, proceed to question number 5. Question number 5. Is it feasible to establish measurable critical limits in monitoring that enable timely detection and correction of all failure? If the answer is no, then it is an OPRP. If yes, it is a CCP. In our case, the baking step as a control measure to eliminate or reduce the microbiological hazards in the material can be considered as an OPRP at question number 4 because the baking process has sufficiently controlled the hazards with no failures encountered. The baking step can, of course, still be a CCP if the failure in the control measures happens, which will lead to question number 5. Critical control point, or CCP, must be determined accurately, but there can be times when it is misidentified or inaccurate. The reasons include incomplete process flow diagram, assigning the wrong severity and/or likelihood rating, incorrect application of the decision tree, misdeclaration of possible hazards, and the prerequisite programs. The HACCP team must be able to overcome these pitfalls to succeed in this step. That's it for this video. In the next one, we'll discuss step 8 of HACCP. Hi, welcome to this next lecture video. In this lecture, we will now define step 8 of HACCP, also known as critical limits. As a definition, critical limits are the criterion to separate the acceptable from the unacceptable. These are the limits pertaining to control measures, and if the critical limit is not met, the products affected are to be handled as potentially unsafe products, and corrective actions must be taken. Once the critical limits are established for the CCP, the processing limits can be developed to establish a robust process control. With the example, the control of the oven temperature and the baking time are the process limits to ensure that the hazards will be within the limits. This step may be short and straightforward, but do not undervalue its importance to ensure the safety of the product and those who use and consume it. We'll see you in the next one. Welcome to our video on the fourth HACCP principle and the ninth step, establishing monitoring procedures. Now, monitoring means determining the status of a system, process, or an activity. Monitoring procedures include what to monitor, the parameter or process or product characteristics to test, where to monitor, the monitoring points to get the data, how to monitor, the methods to be used like through observations or measurements, when to monitor, the frequency of the monitoring can be intermittent or continuous for in-process or extremely critical parameters, who is the responsible person to monitor, the designated person to do the monitoring and his qualifications to perform such activities. Monitoring allows for the collection of data to establish limits, so the data should be monitored in a timely manner, using appropriate and calibrated tools recorded accurately by a qualified or trained person. The monitoring can be done through observation, like visual checking, or through measurements, like weighing or metering devices. In our example, let's take the baking step. What to monitor? For the equipment or process, the baking time and oven temperature is monitored as the process limits, as well as water activity and moisture. Where to monitor? The monitoring point is the end of the tunnel oven. How to monitor? For the baking time and oven temperature, if the equipment displays the values, these can be recorded. Water activity and moisture can be measured using a moisture analyzer device. When to monitor? The reading of time and temperature can be done per batch, same as with water activity and moisture. Who is responsible? The monitoring of time and temperature is done by the operator, while the moisture is done by a trained quality analyst. The procedures for each CCP must be specific and should monitor the control of each hazard, the actions to be taken when the critical limits are exceeded. Some examples of the monitoring procedures include, but not limited to, inspecting of raw material conditions, checking the measurement of the temperature at set frequency, sampling of finished goods for microbiological tests, checking of labels and production codes, visual inspection of the product and equipment. Note, the monitoring procedures will be included in the CCP plan. Aside from the monitoring plan, the actions needed to be taken are included in the plan. This will be covered in the next step of the 12-step HACCP system. That's all for this video in step 9. I'll see you in the next one.